So vigiVec had already been conceptualized and developed by UMC in the past, but needed an extended evaluation of its performance. And we chose this topic because we wanted to explore the domain-specific data that is stored in VigiBase, containing millions of coded adverse events and drugs. And in VigiBase, these adverse events and drugs are coded using dictionaries. So adverse events are coded using the MEDRA dictionary, and drugs are coded using the ATC classification system or the WHO drug dictionary. And within these dictionaries, medical terms are grouped based on their semantic similarities and clinical relationships. And that's also something that vigiVec can capture. So we first trained a 20-dimensional neural network model, vigiVec, to predict co-reported drugs and adverse events for each report in VigiBase. We then leveraged the knowledge learned from this trained model to create the vector representations for each drug and adverse event. And the basic idea behind these vector representations is that, just like with general language, where similar words appear together in sentences, similar adverse events tend to be reported together in drug safety reports. So it's these similarities that are captured by the vector representations, with similar adverse events and drugs having similar vectors close to each other in the multi-dimensional space. And it's this space alignment that allows for the grouping of adverse events and drugs that share a common reporting context. Our finding shows that vigiVec produces stable and clinically related vector representations. vigiVec allows for the grouping of adverse events and drugs based on their position in the multidimensional vector space and independent of their position in the dictionaries. vigiVec representations are not recreating the MEDRA and ATC hierarchies, but rather providing a valuable complement to them. However, it's important to not overlook the value of human coding, which remains an important component. So, vigiVec, for example, can suggest additional adverse events or drugs when searching for reports related to a specific medical condition. It can also help medical professionals with limited familiarity with the standard hierarchies to identify clinically related adverse events and drugs. And finally, it can help domain experts creating new standardized groupings for both the MEDRA dictionary and the WHO drug dictionary.